Okay, so this is problem 21, section 3.3. Let me start with a slightly different problem. Let's start where cosine of u equals negative 1/2. Let's understand a little bit about that, and then we'll move into solving problem 21 a little bit more. So to understand this, let's take a look at its graph. I'll do that on Desmos out of absolute convenience. So we'll get rid of this. Y equals cosine of x, and y equals negative 1/2. So let's see where those two graphs intersect each other. You can see there's an infinite number of points where that happens. So one of them's here, one of them's here, 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 etc. It's an infinite number of points. So it would be nice if we could kind of characterize these a little bit. So if we had a way to just say, okay, it's at these types of points. So when you're working with a cosine, cosine is which coordinate on the unit circle? Cosine is the x coordinate. All right, so we want to know where the x coordinate on the unit circle is negative 1/2. So let's draw that and take a look at what that looks like. Here's a unit circle. Let's add a little bit to that. So center's about here, and we've got our axes. So I want to know, roughly speaking, where does x equal 1/2? What angles have an x coordinate of 1/2? Well, there's going to be two of them, right? Up here and up here. So let's figure out what these angles are. Now this is a little bit of the challenge in working with these types of problems, is trying to find these angles. So let's look for this one first. Basically it's that angle there. And then when we're done with that one, we'll try and find the larger angle, the one in the third quadrant, to here. Now for this first one, well, we can do that with the inverse cosine. What's the inverse cosine of negative 1/2? It's probably not a number that you're going to recognize. Maybe you have the unit circle memorized well enough that you know, okay, I know where the x coordinate is, minus 1/2. But not everyone's there yet. So let me show you a trick that you can do. Let's put our calculator in degree mode, just for the moment. Now typically I'm going to ask that these problems be answered in radians, but sometimes we'll work with degrees. And quite honestly, it's hard to work in radians sometimes because you just don't know what these points are. So hit the second key, then you know what? We got to put it in radian or degree mode first. So hit your mode key, go over to degree, and press enter. So now it's in degree mode. Hit the second key and then the mode key to quit out of there. I want to do the cosine inverse. Cosine inverse has nothing to do with the secant. You press the second button and then the cosine key, and you'll get what's up above that, which is your cosine inverse of negative 0.5, and I get 120 degrees. Okay, cool. That's 120 degrees. So let's take note of that. This little angle here right there is 120 degrees. But there's another possibility. If that's 120 degrees, then we also get another possibility kind of going the other way. Let me mark that in a different color here for us. That's 120 degrees, and so is this. That's 120 degrees. But how should I think about that angle in a positive direction? Well, I could think of it as 360 minus 120. You could also think of this angle as being 60 and then 180 plus 60. Again, you're going to get the same thing, 240 degrees. So what happens if I want all the solutions? Well, I'm going to get a solution here at 120, and then if I add 360, I'm going to be back here again, right? And then I add another 360 or subtract 360 a couple times, etc. So my solutions, if I go beyond just 0 to 360 or 0 to 2 pi, it's going to be an infinite number. You can see that. There's an infinite number of solutions here. Let's see if we can't characterize that. Well, let me go back to this right here. 120 plus multiples of 360. Or 240 plus n times 360. That's the most general solution I have to where cosine of u is equal to negative 1/2. So there's two parts to it. There's this part and this part. Now that's great as long as you're content with something in degrees. But let's change this to radians. What is this in radians? What's 120 degrees in radians? All right, 2 pi over 3. 2 pi over 3. And instead of n times 360, what could I replace that with? N times 2 pi. N times 2 pi. So that's this answer. Or 240 is 4 pi over 3 plus n times 2 pi. Those are the two sets of answers that I get for where cosine of u equals 1/2. Okay. Had I been here last week, I could have gone over some more of this in more detail, etc. Sorry I wasn't around. Let's go back to the problem at hand, though. The problem at hand was this. Secant of this equals minus 1/2. Or it's going to be minus 2. Well, secant is 1 over the cosine. So I can replace it with 1 over the cosine of 3 theta over 2. I can get rid of this then, get rid of the denominator, by multiplying through on both sides by the lowest common denominator. In other words, multiplying both sides by cosine of 3 theta over 2. Essentially, I'm going to end up taking the reciprocal on both sides, is what it'll end up as. 1 equals negative 2 times cosine of 3 theta over 2. And divide both sides by negative 2. This is what I wanted overall. So I wanted to work down to that. Now, this is kind of a problem we just finished solving. I want to know where the cosine of something is equal to negative 1/2. So that much we already solved. The difference is, instead of a u here, we solved for where, the possible values of u was 2 pi over 3 plus n 2 pi, or 4 pi over 3 plus n times 2 pi. I'm going to do a little replacement here. Yes?
Okay. What I wanted to ask is, this is not a double angle, this is not a half angle. What do you do with 3 theta over 2?
Well, right here, I had the cosine of something equals negative 1/2. Here I got the cosine of something equals negative 1/2. The solutions are when this expression either equals this or it equals this. So one at a time, let's take 3 theta over 2 equal, first of all, this expression. 2 pi over 3 plus 2 times n times pi. How would you solve for theta here?
Okay, so basically we're back to like when we did.
We're not using any double angle formulas or anything like that. We're just saying, okay, when is this true? Now, there is kind of a justification for this. If you were to take, if you wanted to see an actual step here in solving, here's what it would be. It'd be the cosine inverse of the cosine of 3 theta over 2, and that's going to be equal to the cosine inverse of negative 1/2. So I wish I had these things reversed here. Cosine inverse of negative 1/2, this one possible solution. Cosine inverse of the cosine, those two cancel each other out. That's how you're getting this here. So that's what's going on.
What prompted this question is Nick, he divided.
Nick's always a troublemaker. Don't listen.
I know. He divided by 2. Now my concern is you do not mess with the angle. You never divide by the angle. That's what I was trying to get to understand or get him to understand.
You mean divide by 2 here before you use...
Yeah, 2 theta, I divided by 2 to basically
Okay.
isolate theta.
If theta was inside here, then you can't divide by 2 like that. Because there's actual identities. And when we get to that, remind me, I'll go back and show you. But if I had 1 equals cosine of 2 theta, I can't divide both sides by 2 and say, okay, 1/2 equals cosine of theta. You can't cancel into that argument. Cosine of theta is actually cosine of 2 theta is actually kind of strange. It turns out to be cosine squared of theta minus sine squared of theta. If you wanted to put something there, this is what it'd have to be. But we haven't gotten there yet. That's two sections ahead. Yeah, for that one, if you had something like this, cosine of 2 theta equals 1, then what you would have to do is take cosine inverse of the left-hand side and cosine inverse of the right-hand side. These two cancel each other out, and you get your 2 theta. On the right-hand side, where does cosine of theta equal 1? Well, 0 or 2 pi. Or if you want to do it generally, 2 theta equals multiples of 2 pi, any integer multiple. Divide both sides by 2. Basically, theta is a multiple of pi. That would be the solution to something like that. Yeah. I'd have to see if you divided by 2. Even if you got the right answer, I'd be pretty unhappy.
I got rid of the cosine, I just had 2 theta by itself. By 2 like you did just there.
Okay, if you can get rid of the cosine first, then yeah, then you're fine. How are we going to solve here? What do you have to do to get theta by itself? Yeah, multiply both sides by 2/3. So 2/3 times this, that's going to cancel. I'll get theta. 2/3 times this is going to be 4 pi over 9 plus 4n pi over 3. And that's the most general solution you're going to get. That's going to give you, an infinite number of solutions for every integer value of n that you set in. Now that's one possible solution. Let me circle that. So that kind of corresponds to something that started out here. The other one is going to be pretty similar. It's going to be where 3 over 2 theta equals 4 pi over 3 plus 2n pi. And there again, you want to multiply by the reciprocal of this coefficient. The reciprocal of 3/2 is 2/3. So if I multiply by 2/3, again, I'll get theta by itself. This time it's going to be 8 pi over 9 plus 4n pi over 3. You can clean that up if you wanted to or needed to, but that's it. Well, because I've got there's going to be two solutions. Well, for a cosine problem like this, there's two places where cosine can be 1/2 or -1/2. So I'm going to have two forms of the general solution. And here's one form, here's the other form. All right, it's a good question. Thanks, Kristen. Charmel? 2 pi is the radian equivalent of 360 degrees. So when I went from here in degrees to over here in radians, or excuse me, here in degrees to down here in radians, 360 got replaced by 2 pi. Okay? Vivek? No? Okay. Okay.